Hello and welcome to this video. It's a pleasure to see you here, and I want to highlight a little bit what we are discussing about today. So first of all, how to start with security inside your DevOps world. So how to migrate from DevOps to DevSecOps. I want to highlight a little bit what tools you have, what are the low-hanging fruits, and how to start efficiently if you have already an existing CI environment. The next thing I want to highlight is what happened with the SolarWinds hack, how this changed our world, our IT world, and the reaction, the executive order from the US President, Mr. Biden. What does it mean? How this will affect our IT environment, how far this will go, and if this is just something for the US area or will it influence the rest of the world as well. So if you're interested in this, all these cybersecurity topics, then you're exactly right now here. By the way, my name is Sven, I'm developer advocate for JFrog, and as you can see, I'm right here in the forest, and we will have two journeys. One is to the DevSecOps world, the other one is to some places here in the woods, so I will take you with me. And if you saw already a few of my videos, welcome back. If you are just here the first time in one of my videos, welcome from my side. It's a pleasure to see you here in this video. And well, if you want to see more about this, check out the YouTube channels, one on the JFrog side and my private one, so I have them in German as well as in English. And it would be a pleasure to get from you not only a few thumbs up on my YouTube videos, I would really appreciate to see you as my new subscriber. But now it's time to start. So what we want to start first, let's see. Who is SolarWinds and why this affected our whole view on the cybersecurity world? Well, SolarWinds itself is a company, a US company, and they have 300,000 customers or so, and they are developing a tool that is able to manage network infrastructure. And guess what's important if you want to manage network infrastructure? Well, you need very high rights. So it's exactly what you need to switch something in this configuration. And the other thing is that if you're managing this infrastructure of a company, then you're in one of these really critical infrastructure parts of the company, because all the communication, everything relies on the network infrastructure. So SolarWinds is a company that built the Orion platform, and this Orion platform is exactly the tool to manage networks. So, but what happened? What happened during the SolarWinds hack and how this infected the rest of the world? So the hacker group just broke into the system from the company SolarWinds, and instead of stealing data or just compromising some stuff that's not working anymore or whatever, they compromised the CI environment. Yes, you heard right. They compromised the CI environment in a way that with every build, the build was not only building the binary the SolarWinds company wanted to provide. No, they added compromised binaries as well. So they have infected binaries now. And having in mind that this company has 300,000 potential customers and an automatic update function, this was a huge multiplicator. So this compromised binary that was now included with every build was provided via this update functionality and then pushed to the customers. On the customer side, it has done nothing, so just sleeping for 1 or 2 weeks, and then it starts loading more binaries to the site where they are active. And this means that every SolarWinds attack is completely different. So they have this main hole, this main binary that infected the system, scanning the binary, start working in terms of infecting more nodes and grabbing more binaries to this to have more functionalities. On the other side, you have opened now a bunch of doors, and you not even know how many doors, what are the doors, and so on. So what do you have to do to get rid of SolarWinds? Well, you really have to shut down the whole infrastructure, clean it, and install it from scratch. Traditional stuff like I'm checking fingerprints from the company that's offering these binaries would not work, because the fingerprint is done over the infected binary. So even if you're checking fingerprints, it will give you nothing. So it will just give you a wrong kind of security. So the next question is, what are the different sides? So what we learned from the SolarWinds hack, what is a big difference compared to others? And the next step would be how to work against this. What can you do to be prepared against something like a SolarWinds hack or whatever attack? What are the different sides of the SolarWinds hack? So first of all, how to prevent that you are not consuming infected binaries. So what's the side of the customer that are consuming stuff, and the other side is how to make sure that you are not this company that is providing infected binaries. So you have now two dimensions, and the other thing is that attacks are not going to the final targets anymore, they are attacking the supply chain. So to compromise your system, you not only have to protect your own system, you have to protect the whole supply chain. And this is something really new. So the quality of the SolarWinds hack was really a new one, and it was something that is not so easy to detect. So what tools or what basic mechanics you have to prepare yourself against SolarWinds hack? First of all, not consuming infected binaries, to identify what's going on, to clean it, and on the other side, don't be the next SolarWinds, so that you are not pushing compromised binaries to the world. What's Dust? Dynamic application security testing is the way to scan the running application. So what you try to do here is that you want to go over the most common vulnerability like SQL injection or whatever to attack a running system to find out if this vulnerability is there. So dynamic application security testing is focusing on testing already running applications, and the best thing is if you're running this one against a production system. What is the opposite of Dust, dynamic application security testing? Well, the opposite is static application security testing. What is the big thing here? So what you're doing is that you're scanning all existing components and the system must not run. So really you're focusing on the static semantic of everything that is included into this tech stack. That could include source code, it could include binaries, configurations, everything that's available. So static application security testing is something that you can do on everything that's not running, and Dust, dynamic application security testing, is focusing on already running applications. But what are the pros and cons of both of them? What are the pros and cons of Dust? So dynamic application security testing implies that you have already an application that is running. So you can't start from the first line of code, you can just start if you have something that's already running. This could be just the infrastructure without your application, but it must run. The next thing is dynamic application security testing focusing on identifying most common vulnerabilities, because the tool stack itself is mostly trained to these most common vulnerabilities like SQL injection. You have this black box testing, so you don't need information about what technology is used or what's internally used or how it's done. You're just testing the, what means just, so you're testing the package from outside. So it's a hacker approach. And this hacker approach is mostly based on these most common vulnerabilities. By the way, I have a video about most common vulnerabilities on YouTube if you want to know a little bit more about this one. But if you want to have new attacks, then you need some other approaches like machine learning, AI-based stuff that is manipulating a little bit the attack vector, or you need the knowledge to simulate this attack, and then you need a way to train the tool to do exactly this approach or to do exactly this cyber attack. So this is not easy, so mostly you need very detailed information about the attack itself, so it's nothing that is usable by everyone. But the core idea is that you have an already existing amount of attacks that you can run against this running application. There's one pro and one con additionally. So one con is that this is very, very late in the software delivery lifecycle. So fixing vulnerabilities identified by Dust are mostly more expensive to fix because you have to do all this work again. The good thing is, if you're testing against a production system, you are able to identify all this runtime and configuration issues as well. So if you have a bad configuration, this will open additional ports or this will open some attack vectors. You are able to identify this with Dust. This is not possible with Dust, what I'm explaining next. So yeah, this is a good approach, but have in mind you're focusing on most common vulnerabilities. You need something that is running, and test it against a production system, not against a test system. This makes no sense because all this runtime environment things you can identify with Dust are only valid if you're testing production and not test systems. What's SAST? Static Application Security Testing, and the pros and cons. So first of all, with SAST you have this white box approach, so that you're scanning all components of your test stack, not only from outside, you're really testing every component that's inside. The good thing is you can test 100% of your system directly or indirectly. It's possible with Dust, but directly it's just able if you're using SAST tools. So it means really focusing on the static semantic. What is a good and bad thing in terms of cause and fixing vulnerabilities? First of all, you can search for vulnerabilities as well as for compliance issues. This is not possible if you're just looking from outside, but if you're looking inside, you have all components, and then you can check what is the license this is running under, and then you can decide if this is something that is affecting your business. You don't need a running application, so you can really start from the first minute, and if you're able to identify vulnerabilities or compliance issues, it's mostly way cheaper to fix this one because you're way earlier inside the software delivery lifecycle. On the other side, it's not possible to find zero-day attacks because you have no information about the runtime environment, about the configuration and the behavior of the application itself, because this is all inside the dynamic context. And with SAST, you are focusing 100% of static application security testing. It means on the static semantics of these tools. What can you scan? You can scan source code, binaries, configuration, everything, but have in mind you're missing the context this application is running in. On the other side, you can scan on every developer machine. So compared to Dust, that must be tested on production, SAST can be done on every machine because you are focusing just on the components. And this will lead you to the possibility that every developer in the team can start with static application security testing on every machine, on every CI build machine, whatever, because the runtime is not important at this testing technique. Okay, we saw the pros and cons of Dust and SAST, and what should I focus on? Well, in an ideal world you will have both because they are both working hand in hand very efficiently. But if you just starting with security, and you're looking for the biggest impact or for the low-hanging fruits of security, you should focus on the SAST part because this is by far the broadest part, and I will explain why you should focus on SAST, because it will help you to fulfill a lot of other requirements that are just coming from US. But first of all, what should I scan? What will have the biggest impact if you start with security and you want to have the low-hanging fruits? Well, the static application security testing will help you because you have access to 100% and you can scan 100%, and you can scan against vulnerabilities and compliance issues. But what is the best part to start with? Should I scan my source code? Well, looking at the source code part means that first of all, this is a very tiny part compared of all other binaries in the system. And the other thing is, what can you identify if you're scanning source code? You can identify if your source code is invoking some critical functions. Okay, you can try to identify patterns that may be able to be misused. So, and all this may be and will just say exactly what the current state of this is. So we have machine learning based stuff, we have AI based stuff, we have pattern matching stuff, but all these tools are focusing first of all on a very small part compared to the whole system, because the biggest part are dependencies. And the other thing is that you don't have this context here, so you don't know how this will be invoked. If there's something, for example SQL injection, is there something that makes sure that there is no compromised input possible or whatever. So this is a little bit tricky, and the existing tools here, they will help you identify smelling code, but it's not easy, and compared to the amount from the whole test stack you're scanning, this is something I would not focus first. So this is something additionally, this helpful for sure, and maybe in a few years the tools that are available are way better than today, but to have really a big impact you should focus on binaries. Should I scan binaries? And I would say yes. Why? Binaries are by far the biggest part of your system. So if you're looking at everything in your tech stack, so I don't only mean what you're creating by yourself, but all other dependencies. So how many dependencies you have in your project, how many binaries you're using, the operating system, the Docker layer, the Kubernetes universe, the whole tooling part, so your CI environment, your JDK, your compiler, whatever. So if you're checking everything, so if you're looking at this one, binaries by far the biggest part in your whole tech stack during runtime as well as during the production. And then it makes sense to scan all binaries. Looking at the SolarWinds Hack, they compromise the CI environment. And just a question to you, did you ever check your CI environment against vulnerabilities? Well, but it makes sense to check all these binaries because they are available, they're easy to identify, they're easy to, what means easy, but they're good in terms of how to identify vulnerabilities, compliance issues, and if you have something like a package manager, you have all the metadata around. So this dependency is based on the following dependencies, directly or indirectly. So should I scan binaries? Yes, because this is the biggest beast and you can scan against non-vulnerabilities as well as compliance issues. And this is the biggest amount of weak points you will have inside your system. Okay, what are the requirements for a good binary scanner? So if you should focus on scanning binaries, you need a good binary scanner. And what are the requirements? The requirements are mostly based on the metadata, not on the scanner itself. So scanning one binary is one task that's well defined. So you have the input, you're scanning the binaries, you have some metadata, maybe in terms of I can identify via fingerprint, this is this binary and exactly this one. So you can have this blacklisting or whitelisting approach. But what's really impactful is if you have all metadata around this binary based on the package managers. So mostly all dependencies in a system, direct or indirectly, are managed by package managers. And if you have the knowledge about a package manager, you know all this meta information around this, so direct and indirect dependencies. Sometimes you are able to identify even the dependencies over technical borders. So what are the best requirements for a binary scanner? The knowledge about package managers, access to these package managers, being able to go over technology borders and not only focusing on one tech layer. So a binary scanner that's just focusing on Docker layers is not so good as a binary scanner that can scan the Maven dependencies, the Debian packages, the Docker layers, the Helm charts, and all the stuff where this tech stack is running in. So these are the requirements for a perfect binary scanner. So one question might be, what tool should I use or should start with? Well, I would recommend to have a look at the free tier, because there we have Artifactory and we have X-Ray. And Artifactory is a package manager, so you have exactly all this meta information about the package managers itself, so direct and indirect dependencies. You have the information about the build itself, if you're using build information or storing build information there as well. And on the other side, X-Ray is scanning over all these package managers and technologies. And the best thing, inside the free tier, you can use it for your own projects, privately or commercially, for free. So you just register for the free tier or come to one of the workshops. I will show how to deal with this one, or just try it by yourself. If you want to know how to start with this one and you are not able to wait until the next workshop will start, just go to my YouTube channel. I have a few how-tos, how to start and ramp up a basic project and the free tier. What is the right time to scan binaries? If you're focusing on scanning binaries because this is the biggest part, so make it sense to scan them during production or inside the production environment. Well, to say the truth, my personal opinion is that it doesn't make sense to scan binaries in production, because you have all these previous steps, and inside production you don't have more information about the static semantics, you just have additional information about the runtime environment. So your tools that are scanning for static stuff makes no sense to use. So in production, the only thing is monitoring and dust tools, because they can use the environment and configuration and all this meta information that's available in runtime systems. So scanning binaries in production, my personal view is makes no sense. So what is a better place? Okay, if scanning binaries makes no sense to do it inside the production time because you don't have additional information that you can use for static analyzers, then what is the right time? Okay, so it means you must do it earlier. Before I'm talking about what are the previous steps, I want to highlight the term shift left, because you will find this in documentation or other videos as well. And shift left is one thing that means that if production is on the right side and start writing code is on the left side, all the steps in between you have. If you are going more to the left, it means you are shifting left, so you're pushing something more to the left, more to the beginning of the production. And yeah, read a little bit more about on Wikipedia or other resources you will find in the internet. So shift left means pushing more and more to the beginning, to the root of creating or consuming or adding vulnerabilities. So right side is production, left side is the concept phase, and now we start shifting more and more left, because what is the best part to scan and what are the different steps you can use? Okay, if shift left means that we are going from production a little bit more to the creation process, to the left side. What is the next part? The next part is the CI environment. So everything that will be built automatically after you coded something, everything that's preparing the binaries that are running in production. Make it sense to scan inside the CI environment? Yes, definitely. Because here you're composing all the final binaries, here you're consuming all binaries. This is a working horse, the CI environment, so it makes sense that here some kind of scanning is implemented, because everything should go through this final step. So it's the last border before you are going to production, and the machine is doing a good job, so because it's doing always with the same quality, with the same speed and with the same behavior. Yeah, scanning inside the CI environment, definitely. So shift inside your CI environment. What is a bad thing? The bad thing is that you wasted already some time during the coding time. So is there any previous step you can use additionally to scanning inside the pipeline? Yes, we have one step that is a bit more powerful in the beginning of the production phase. What's more left than scanning inside the CI pipeline? Well, this is immediately inside your IDE. So shifting left inside the IDE has some pros and cons, and it's one of the earliest parts where we can start scanning against known vulnerabilities and compliance issues, and we definitely start investing time. We not even have already invested time. This means if you're scanning inside the CI pipeline, this is good, because this is a final border, this is a quality gate you have to pass. There is a verification, but to find to work or to fight against known vulnerabilities and compliance issues, the better place is inside your IDE. Because what are you doing if you start coding? You're writing a few lines of code and then you start adding some dependencies, and this is exactly the right time to scan, because if inside your IDE you will get the information, oh, there is a vulnerability, or this is a wrong license, or there is an indirect dependency that doesn't fulfill our requirements, you can react immediately. You can stop using this library, you can change it, you can change the version, whatever is necessary. So inside the IDE, you wasted less time, less money. You are mostly more flexible as changing during the CI phase. And this means fighting against non-vulnerabilities and compliance issues. The best place from my personal point of view is you should start inside the IDE with this. And well, if this everybody in your team is doing, then vulnerabilities will have nearly no chance. What's the lesson learned from the SolarWinds hack? Well, first of all, what is new? So the new thing here, and the big thing here, is that the attacks are not against the final targets anymore. The attacks are against multipliers, against supply chains. So it means that instead of focusing on the targets they want to hack, they're going to somewhere who's delivering something. So they're going to some part in the delivery chain, and this will lead to a few questions. For example, are you part of a delivery chain? Are you part of this target they want to reach? And I would say yes, definitely. We are directly or indirectly now targets, because the SolarWinds hack is not focusing on the main things they want to get. Now they are focusing on everybody that is somehow related to this supply chain. So if SolarWinds is affecting the supply chain and try to find multiplicator, so is this a risk for us? Yes, definitely, because we are consuming binaries. We are consuming so many binaries. So during the time we are coding, we are adding dependencies. So we are consuming binaries. We are using technologies like Docker, Kubernetes, the servlet container, whatever. Yes, this is consuming binaries. We are using operating systems. We are consuming binaries because we are not writing operating systems by ourselves. And have in mind includes the whole tech stack for your production as well. So scan your CI environment, scan your linker, your compiler, your tooling, what you're using, because these are all binaries that can be or could be compromised. So we are consuming binaries, definitely. Should we scan all of them? Definitely. But what was the other side of the SolarWinds hack? The other side of the SolarWinds hack, yeah, definitely, it was distributing binaries. Are we distributing binaries? Oh yes, because I'm coding some stuff and then I'm distributing. I'm distributing to our production system, or I'm distributing something that our customers are using. I'm distributing binaries because I'm offering a free open source project, whatever. So we as a software developer, we have now these two angles of the SolarWinds hack. We are consuming binaries, definitely, and we are pushing binaries. We are multiplicators. So this means we should be aware of what's going on of the whole supply chain, and this is what we learned from the SolarWinds hack, scanning the whole supply chain. So we are not the only one that learned from this SolarWinds hack. So lesson learned. Well, even the US government got a big lesson learned, because governmental institutions, departments also were infected by the SolarWinds hack, and this was bringing a big wave inside their internal communication and structures. And this was leading to the executive order. And who gave it? It was a Mr. President, Mr. Biden from US, and he gave an executive order on or off cybersecurity. So it means there was a statement. It was related more or less to the SolarWinds hack, because this was definitely a new quality, and the impact of the SolarWinds hack was huge. Because to get rid of SolarWinds stuff, you're not even removing a binary, you really have to remove the infrastructure and ramp it up from scratch. So what is the lesson learned? So who gave this one? It was the president of the from US. And why? It was a reaction on the SolarWinds hack, but me as a non-native or non-US citizen, I never heard about term executive order. So what is an executive order and what does it mean? The first time I heard this term executive order, to say the truth, I had no clue what does it mean, because I'm from Germany. I have no clue about the governmental structures and the rules and all this stuff from US. But I started reading a little bit, and what I found out, so I'm not a lawyer, so it's just a very simplified explanation, but the executive order is coming from the CEO of the company US. So let's say the president is the only one that can give executive orders, and if you look on to this president, like the CEO of a company, what can he do? He can influence the way this company is working. He can't change the rules outside without any rule. So he cannot just decide we are increasing taxes or decreasing taxes, or we are changing some law or whatever. But he can give this executive order. That means how this governmental organization is operating. So, and if this executive orders is against the law, the US law, then there are some other institutions that can work against it, or can say this executive order is not right or whatever. So I'm not very detailed informed about this one, but the main thing is an executive order will influence how the governmental structure will work. And the executive order of cybersecurity will make sure that everything that has something to do with software that is used or produced by the US government will be infected by this executive order. And then is the next question, how is this legal binding of this one? So what is this? And another question is, why should I care about an executive order in US if I'm in Europe or somewhere in the world? And these are two questions I want to have a short look at now. So how is an executive order from the president, and he's the only one that can give this executive orders, how this legal binding? So there are several rules. So the executive order can only be done for how the government works, so for internal structures, how this is operating and what are the rules. He cannot use an executive order to increase taxes or decrease taxes or change law that's affecting everybody on the street directly. So for this they have other structures, but mostly it's in a way that this executive order is influencing the governmental structure, and the governmental structure and how it operates will influence directly or indirectly the economy as well. So the main question, how is this legal binding? Well, it's just an advice, or it's a construction that will change how the government internally will work, and then they will check if this is against law, yes or not. Okay, there are a few things left. So first of all, what is the content of this executive order? So what they are defining. So the executive order is now describing this SBOM, the software bills of material, and you need a fully list or description of all software components that are used directly or indirectly. Speaking in terms of Java, for example, if you have a Maven dependency, it's not enough to write down, I'm consuming the dependency A, B, and C. You need to write down what dependencies these dependencies are using. So all direct and indirect dependencies. The next thing is, it's not only for the software that is created, it's for the whole tech stack. So all software that is running must now be included in this software bills of material. And this is a huge thing. On the other side, it's something like the complete documentation about every tiny piece that's running. Will this infect us, or will it change something? First of all, it will immediately change something on the US market. So everybody who is directly or indirectly producing software for the government or something that is used by the government have to fulfill this requirement for sure. So they have to create these bills of material. On the other side, will this affect parties outside of US? For sure, we are globally connected. So if we are creating something that is used by a company that's providing something that's delivering to the US company or to the government directly, so how long this tail is doesn't matter. So it's really, we are infected directly or indirectly by this executive order because we have to fulfill this SBOM now. It's more or less like the GDPR that was coming from Europe. So we defined inside Europe how we want to deal with data protection, and then the requirement was for external companies as well, like these big cloud providers or whatever, and this would be the step to push all this stuff to the US. So GDPR was coming from Europe and was swapping to US. Now the executive order is coming from US, and it will definitely swap to Europe and the rest of the world as well. So yes, we have to prepare to fulfill these requirements. So next thing is, before we are going to this SBOM topic again, I want to see if we have already something that we can use to fulfill this requirement, and yes, we have something. So let's talk a little bit about the full impact graph if you're searching for vulnerabilities or compliance issues. Compliance issues is one thing. You want to check if there's no component with the wrong license, but I'm focusing here right now on vulnerabilities, because with this you need a full impact graph. Why? A full impact graph means if you have a vulnerability inside, let's say, a jar, a Maven dependency, and this one is wrapped inside a web archive. It's used in this web archive. This web archive is then embedded inside a Docker layer into a servlet container, and this Docker layer is part of a Docker image, is part of a Helm chart, and so on. What we need is a full impact graph. We need the information that this infected binary is used in these different layers or in different technologies as well, so directly or indirectly. And this means, this will lead us to a dependency tree, and we need knowledge about different technologies and the metadata of this dependency. So we need knowledge about dependency manager. And yeah, so the main idea here is that you don't trust your direct and your indirect dependencies, because you have to scan them to make sure there are no vulnerabilities. If you are able to do this over different technology borders, then you are able to extract this dependency or this impact graph. And I mean the full impact graph over all tech layers that is somehow used in your production system. Okay. We need a full impact graph, but how to extract this full impact graph? For this, you need one logical point where you have access to all dependency managers, because if you have access to all dependency managers that are used, you have access to all metadata. And we have this dedicated place, and that's called Artifactory. It's more or less the manager of repository managers. And if all dependencies are going through this logical point, this Artifactory, you are able to build the whole dependency tree. And the next thing that is able to scan binaries is X-Ray. X-Ray is connected to Artifactory, and with this we have now the possibility to have one logical point where all binaries are coming through from Maven, Debian dependencies, Docker images, Helm charts, whatever is used from your project you are building, from your infrastructure, really everything. And then X-Ray is able to read all this definition, so it knows what's already in the system, what is depending on what other technology or other dependency. So we need one logical point, and we need someone who's able to read this meta information and has access to this logical point. I mentioned X-Ray in combination with Artifactory. X-Ray is a binary scanner, is a scanner for vulnerabilities and compliance issues. So how this works. So X-Ray has all the information that's inside Artifactory. It could be dependencies between technology borders, it could be build information, distribution bundles, and so on. And with this information, we are able to scan these binaries and reading metadata to bring this in some kind of context. And I just want to highlight how we are extracting or dealing with X-Ray just in a few words. So we have one concept called watches, policies and rules. So with rules we are describing in atomic steps what should happen if we are finding a vulnerability or compliance issue. Then with policies we are aggregating these rules so that we have composites of rules, and then these policies are used inside watches, and watches are the combination between the actual repositories, the binaries, and the policies, the description, what should happen here. So I have a very detailed talk about this one. We have webinars about this, we have workshops how to use it. So if you want to try it on the free tier, just register for the next workshop. But the basic thing is we are able to describe what should happen based on CVSS scores, based on what technology we want to scan, and so on. And then we have some reactions. So X-Ray can start webhooks, can break a build, can send emails, can block downloads, and so on. And all functionality is available via REST API as well for Artifactory, X-Ray, distribution, and so on. So with this we are able to integrate in every ecosystem that's already existing, or you can just create dynamic workflows with this. So I found the vulnerability, I'm going to this reporting system, the reporting system will call me, give me all this data to extract, and so on. And this is the first step for two things. First is how to extract the full impact graph. Is there something? I will show you in a short screencast how to extract it, maybe of the web UI. But on the other side, if we have all this information, we can deliver not only the full impact graph, we can prepare the SBOM as well. And this is why I think this is a very good win-win situation, because with already fighting against vulnerabilities. We have in place all the technologies we need to fulfill the executive order on cybersecurity for the US government as well, because we are not only able to extract the full impact graph, we are able to extract the full dependency tree, the SBOM, the software bills of material as well. So, what are the next steps? The next step I want to do is I want to show you inside a screencast. Don't worry, it's a short screencast. It's just how to extract a full impact graph so that you have an impression how this will work inside the web UI. Have in mind that all this information is available via REST API as well and command line interface, so you can really feed other machines with this information. And yeah, that's what I want to show you now. So stay tuned for the screencast, how to extract the full impact graph in X-Ray. After you logged into your JFrog platform, then you have this overview window. If you don't have access to JFrog platform already, you can use our free tier offering, and I will give you the link here somewhere in this video so that you can start your free tier and you will have access to pipelines, Artifactory and X-Ray. Before you start with X-Ray, you need some repositories with some content in, otherwise you are not able to find something. How to create different repository types or different repositories and how to use them, I will cover in different video. Check out my YouTube channel for this one. You will find, for example, in how to create Maven repositories. If you have already repositories with some content, you can immediately start using X-Ray. For this, you need two things. First of all, the web UI that you are using to see what vulnerability issues and compliance issues you found, and you need the definition of the policies, rules, and watches. What I'm not covering here in this tutorial is how to connect with your IDE plugin to this X-Ray instance. Even this is available for the free tier. And if you want to know more about this one, check out YouTube for some tutorials about this one. Okay, now we are ready to start configuring X-Ray so that we are creating our first policies, rules, and watches. If you want to start with this one, go here to this icon, administration, down to X-Ray and watches and policies. Okay, what is the basic concept here? The basic concept is that we have policies. Policies are a composite of rules, and these are stateless, technology-free description what should happen if you find something. On the other side, we have watches. Watches are the combination between your policies and actual technology-bound repositories, so Maven repositories, Docker repositories. First, we have to create policies with rules. To create a new policy, we're going here to New Policy, and we have the possibility here to give this policy a name. Think about a scaling naming schema, otherwise you will have just a mess of different policies, and I will create a demo policy. If you want, you can add a description, and you have to check here if you want to cover vulnerabilities or license issues. With a free tier, we are focusing here on the securities. So we're scanning against vulnerabilities. The next one is how to add some actions. For this, you need rules. We're creating a new rule. You will get this overlay window, and the first thing you should do is giving this rule a name. Here, I'm choosing a simple name, demo rule. The next thing is that you have to decide what range of CVSS values you want to cover with this rule. You can define them by yourself, or you can go to one of the severity groups, and they are from everything of a low, medium, high, and critical. By the way, if you don't know exactly what CVSS mean, check out my YouTube channel. I have a dedicated YouTube video about the basic metrics, temporal metrics, environmental metrics, and so on. So to get a full understanding about what is CVSS. The video is called CVSS Explained. Here in this video, I'm just want to see everything. After this, you can define what actions should happen if a vulnerability is found. The thing that you can't deactivate is generate violation, and generate violation is for creating an item inside the web UI. Additionally to this, you can trigger webhooks, notify people via email inside this platform. You can block downloads, or you can fail builds, and so on. By the way, all the functionality is available via Web UI as well as REST API and the command line interfaces. If you decided what you want to do, in our case, just create this violation, we press the button Save. Now we have a policy associated with one rule, and this is enough to create the policy. After the policy is created, we can now start combining this one with watches. Watches is a combination between a repository and the policy. And for this, select the menu item, the tab here in this case, watches. Go to New Watch. And the first thing you should do is just use or choose a good name for your watch. Additionally, you have to select what kind of repositories you want to scan, build informations or bundles. I'm focusing here on repositories, so we are selecting repositories. These repositories must be created before you're creating policies, rules and watches. And I'm choosing here, for example, some Maven repositories I created before. For example, Maven Central. And save. The watch has now a name, it has associated repositories, and the last step you need to do is you have to associate some policies. So for this, manage policies, check the policy you created, and you're ready to go. The last step is create watch. So now, what is the time or what's the time point that the watch will change its content? If you trigger it manually, if the vulnerability database will get an update, or if the content of a repository is changed. These are the time stamps that this watch will be fed with new informations. Okay, I created a few of them a little bit before I recorded this video, so we can now have a look on how to use watches. If you want to use a watch, then go to Application, Security and Compliance, Watch Violations. You will get an overview of all watches that are created in this system here or on your platform, and then you can choose exactly a watch you want to check, and you will get an overview of all violations. The pre-selection is created last 7 days. If this watch is a little bit older or this is a repository with less activity, it's sometimes necessary to select a different time range. I'm here just using all and start searching. You will get a list with all these vulnerabilities found. If you want to pre-filter, you can go to min severity and, for example, say here that you just want to have all high or critical vulnerabilities. Searching again, and you will get the subset. I'm taking here the first one. You will get an overview window with a description, type, the full impact graph on the right side so that you can see this binary is inside a Docker layer, for example, and used in this Docker file. And one interesting thing is that for the most of them, we have the CVE values or IDs if they are provided. With this one, just go to Google, search for them, and you will get additional public available information. Okay, after we created watches, we have a second thing we can do inside the web UI. Inside the web UI, we have the possibility to create vulnerability reports as well. For this, go to Application, Security and Compliance, Reports. Reports are ad hoc queries against repositories with some predefined rules like what CVSS ranges you want to search for. For this, go to New Report, give it a name, what kind of report you want to have. In this example, we are searching for vulnerabilities. The scope here is scanning of repositories, and we are selecting some repositories. Again, select some repositories you want to check right now. And after this, You have the possibility to get some additional informations like CVSS range, CVE value, dates until publish, with fix, without fix, and so on. Choose what you need and generate the report. It will take some time based on the amount of binaries that are in the selected repositories, and you will get an overview. To see what's here, click the repository name and you will get an overview. Slightly different to watches, but you will have the CVE, a summary, if it is a high, critical, low, medium, whatever group associated. You will get the different CVSS values, CVSS 2 and 3. If you click on this number, you will get an overview about the components of the CVSS value and components, impacted path, and so on and so on. After this, you can decide if you want to export it like a PDF, CSV, or JSON, and then you're ready to go to use this data. So slowly the weather is changing. So the weather forecast told me that we're expecting a thunderstorm a little bit, maybe in an hour or so. So it starts raining a little bit. So, but it's a perfect time to wrap up anyway. So it's time for the conclusion. So what we learned so far. So first of all, what we learned is what is a SolarWinds hack. So what happened here? So with the SolarWinds hack, we have no attacks not against the final targets. We have against it the supply chain. So we are infected, or we are we have to prepare ourselves. So not only checking what we are using, checking what we are producing as well. So scanning our own infrastructure, not only the dependency we are using during the coding phase. So this one thing, we saw a little bit the difference between DAS and SAS, so dynamic application security testing for testing runtime environments, good for finding bad configuration, open ports and all this stuff. On the other side, we have we saw something about SAS, the static application security testing, and this is by far the low-hanging fruit, or the first thing you should focus if you start with security, because with this we are scanning all components, all static environments or parts of this environment, so we can test 100% and we can scan for vulnerabilities as well as against compliance issues. So should you scan your source code? Well, maybe, but this is just an add-on. Focus on binaries, and scanning binaries means that you must have a place where all binaries are coming together, so that you have some meta information about not only the binary itself, but about all dependencies. For this, Artifactory is a perfect place, because here you have a manager that's able to manage all the dependency managers, and with X-Ray we are able to read this information, not only the binary itself, we have not only access to the binary, but at the same time we have access to all the meta information, so we can extract the full impact graph. Why do we need the full impact graph? We have two things why we need it. First of all, we need a full impact graph to start cleaning our system, so that we see the vulnerabilities are used somewhere in the system directly or indirectly. And on the other side, if we are able to extract the full impact graph, we are prepared for the executive order, and this executive order will just push the government to creating SBOMs, software bills of material. And for this we need everything that we are using actively, or also directly or indirectly. And it's just a question of time that the requirement for the government will affect the economy in US, and it will affect the economy worldwide. So wherever you are, start preparing for this executive order, for this creating SBOMs, the software bills of material. And with Artifactory and X-Ray, you have all tools in your hand to do two things: fight against vulnerabilities and compliance issues, even inside your CI environment or inside your IDE. So shift left is possible, straight down up to the down to the IDE. And on the other side, you have all tools in your hand to start creating SBOMs. If you want to know more about this, I will create a few more webinars to topics a little bit more specific on different parts of this. If you want to have a hands-on experience, well, just register for one of the next workshops I have. So every few weeks I have workshops for DevSecOps, and I will show you how to use X-Ray, how to ramp up, how to use a free tier. If you don't want to wait, just check out my YouTube channel. I have a bunch of YouTube videos explaining how to start with a free tier and how to start with X-Ray. Feel free. Otherwise, well, start raining. It's really time to wrap up now. So you are able to reach me on Twitter, on LinkedIn, on YouTube. If you want to see way more of these outdoor style IT videos, then just check out my YouTube channel. I would really appreciate to see you there as my new subscriber. Otherwise, thank you for watching. If you have any questions, suggestions, just let me know over social media or in the Q&A phase. And that's it from my side. I have to pack up now. I have to find a dry place and wait. I think it's a thunderstorm. They estimated 1 or 2 hours, and then I will start going home slowly. Okay, so thank you for attending. Have a nice day. Stay safe and see you.